I want to do the 6 trigonometric derivatives, but before that I want to talk about the rules that I asked you to kind of review over the weekend.
Miss Kay,
Yeah.
have you gotten your water yet?
No.
Yes.
Just call me sore.
Because they're gone.
Yeah. Oh, yes. We filled out with water twice on Sunday,
Really?
and then
Oh, that's a cough.
I neglected to write power rule. So
I was gonna say, I was like, is she just?
I just threw the rest up there.
It's a simple.
Wait, are
I
those?
most definitely know.
Wait, so
that's
the
the
6
one that everyone
trigonometric
knows.
things is different
No
from
one
all
knows it.
those.
Sarah knows it.
Kinda.
We're going to talk about the rules first.
Okay.
We're going to talk about the functions, tie them together.
Let's just not talk about
Then we're going to talk about the LNs again.
it. Oh, no.
Tie that with it. Oh, yeah. Okay, so the power rule. If our function is y equals x to the n,
nx to the n minus 1.
okay, y prime, instead of y prime, what else could I have written?
dy over dx.
dy over dx. Either one works, right?
Mm-hmm.
Are we good? Okay, any questions about how that one works? That should be really, really comfortable for you guys. Should be very familiar. We're okay with that?
Mm-hmm.
Okay, product rule. So the product rule is if I have two completely different functions that are being multiplied together. Okay? Does anybody recall? Yes.
Isn't like one times the derivative of the other plus the derivative of the first times the other?
Right.
Yep.
So the derivative of the first times the second plus the first times the derivative of the second. Okay? Does that make sense to all?
Mm-hmm.
So let's say we have 2x plus 1, x squared minus 1 are my two completely separate functions.
Mm-hmm.
I call f of x the first thing. I call g of x the second thing.
Mm-hmm.
Okay? So if I'm using the product rule, the derivative of the first would be what?
2
2
x
times the second as it is, plus the
Two-
first
2x plus 1
times the derivative of the second.
2x.
Okay? At that point, the calculus of the problem is complete.
And then it's back out.
Now it's just back to algebra, right? Remember, calculus is this much calculus and a whole lot of algebra. Did you want to try take it now? Okay. So we're going to distribute, we're going to add like terms, we're going to clean it up. A little bit of math magic. So 2x squared minus 2 plus 4x squared plus 2x for a total of 6x squared plus 2x minus 2. Any questions, comments, concerns, issues? Are we cool? So that's product rule.
Yeah, you put those, like, and also, you put those numbers in as just like an example, right?
Yeah, concrete example. Quotient rule.
Low d high minus high d low over low low.
I agree. So, is everybody good with that one? Working it out that way? Instead of doing like the technical way to do it?
What is this?
So, I'll show you. Okay. It's low, high.
That's a lot of work.
My AP Calc friends.
Right, right?
Yeah. They were like, one of my friends was like, "You're good at math, help me." And I was like, "Low behind minus high, low over low low." And she was like, "What?" And I was like, "Look, it's so easy." And she had like F to H. It was like, I was like, "What are you
Right.
doing?"
That's the way they teach it typically.
Yeah, and it was. I was like, "This literally makes no sense, even though I understand it."
So this is considered the high, this is considered the low. Top is high, but low is bottom. So low, D high, minus high, D low, all over low low. Now, question that people can make a mistake on. Yeah.
Don't we like switch the G to the top and then do, isn't there like a way you can do it that way?
You can use product rule.
Yes.
Okay, yeah.
I thought this was like easy substitution, easy substitution.
Not yet.
That's chain, right? Or that's integral.
Integration.
Not yet.
Chain is.
We're going to use chain.
Miss K?
Yeah.
So when would you need to use the quotient rule?
Something that looks like this. Like that.
Even then, couldn't you just pull the X up to the top?
How would it look?
The bottom.
Bad.
No. No, I mean,
Then you just
literally,
change
how would it look? It would be x plus 1 times 2x minus 1 to the negative 1.
And then you just do chain rule and then
Right. So
plug
you
that
product
x
rule
plus
with chain rule intertwined.
Yes.
Yeah.
Either one.
Yeah.
Either one will get you the same spot.
Because I know I never used the
Yeah,
question
I've
rule, I just
never-
always-
I never use quotient rule.
I
Cool.
never used the low D high.
Okay,
Me
cool.
neither.
It's good to know.
Yeah, you might want to know it. Okay, so if I was going to use the quotient rule, it would be 2x minus 1 times 1.
Minus.
So, and the common mistake is to forget it's minus with division. So minus pi d low all over low.
Yes.
So you do a little math magic, you distribute the 1 through, you distribute the negative 2x, if you think of it that way, and then leave the bottom ugly, 2x minus 1 squared. Does that make sense to all?
Mm-hmm.
So you'd have 2x minus 1 minus 2x minus 2 all over 2x minus 1 squared. And so you get what, negative 3
Yeah.
over 2x minus 1 squared.
And we can just leave that as the answer.
Yeah, please do. All right, what do you think so far? Power rule, pretty simple, product rule. Okay, quotient rule. All right.
Miss K?
Yeah,
Could you do that same problem, but like with the where you flip it, the bottom to the top?
in a minute, we're gonna do chain rule.
Okay.
Uh-huh. Okay. I remember what we're hearing to do chain rule. Okay. The good news about this particular chapter is really not a whole lot new. The LN stuff was a little new, a little fresh, but the rest of it is just kind of pulling it all together and reviewing.
See, I had like night terrors about that E of x, that y equals E of x.
I don't remember.
You're choosing not to remember, my friend.
Oh, he's just blocking out a traumatic event. That's all.
All right. So, something that's in the format of f of g of x. Okay? What I mean by that, let me give you some examples. Okay? What's the f of x in this case? What's the outside shell?
X
So squared.
Whatever squared, right?
Yeah.
X squared, yeah.
What's the inside g of x in this case?
X squared plus 1.
Right. Okay.
Right, okay.
Makes sense?
Yeah, so g of x would equal x squared plus 1, and then f of x equals x squared, and you plug in g of x
Into
for
f of x, right. Something like this. Outside shell to the
Negative
So
1 half, right,
1/2.
right? Jump to 1/2. So what's the inside? X cubed minus 1.
Yes.
Is that making sense to all?
Yeah.
So you
If-
can recognize what's the inside, what's the outside, okay? So how this works is the f of x represents the outside shell, where the inside stuff is what's inserted, okay? So if I'm gonna do the derivative of this, it's going to be the derivative of the outside,
Mhm.
leave the inside junk alone. So far, so good? And then times the derivative of the inside.
Miss K?
Yeah,
I'm just confused. Where did you get the square root of x cubed minus 1?
I made it up.
That's another problem.
These are examples of what
Oh,
when
I
you could
see.
use the
Yeah.
chain rule. Okay. Are we good so far?
Yes.
Mm-hmm.
Yeah.
Okay, so let's use these examples to kind of do this problem. So look at the concrete. So we'll do example number 1. And I want to use the chain rule, okay? So I take the derivative of the outside shell first and leave the inside alone.
So if it's
So what would it be? Like, if this was just something squared, how do I take its derivative?
2x to the
So
first.
2 come to the front, rewrite the junk from the inside,
To the one.
and then subtract 1 whole. Very good. So that's the outside shell's derivative.
And now you have to get the inside derivative.
Now we gotta take the inside derivative, which is
2x.
2x.
That's really easy.
It's better this year, right?
Yeah.
So you kind of clean it up. You got 4x times x squared plus 1. And because it's to the first power, I still can distribute the 4x through. So what, 4x cubed plus 4x. Are we good? Makes, I mean, it's like, oh, well, okay, that's easy enough. Now, what about this guy? First of all, I would rewrite it. Instead of a square root, I would write it to the,
1/3 or 1/2.
yeah. Is everybody okay with that? Okay. Same as before. Forget the insides there for a moment and take the derivative of the outside shell. So 1/2,
Write the thing on the inside.
leave junk alone,
-1/2.
subtract 1 whole. Are we good so far?
And then it's 3x.
And then the derivative of the inside is 3x
Square.
x squared.
Oh, right?
Okay. Does that make sense to all?
And then
Okay.
you clean it
And
up.
then you could clean it up. The things that you could do is this could flip to the bottom and pair up with the 2 while this stays on top.
Yes.
If you wanted to clean it up a little bit, it'd be like 3x squared over 2
Times.
and then x cubed minus 1 to the 1/2 or square root, however you choose to write it.
Which is gross.
Yeah, but that's
It
okay
works.
because this tells me a lot about the curve itself, and we'll get into that. Like,
Oh, that's this year.
yeah, it tells me a little bit about what happens on that particular
What are the
curve.
2 come
Asymptotes.
when you switch
The
it
1/2.
to
Right, right. Okay, so the question that Nick had earlier is how would we do the x plus 1 over 2x minus 1 with product and chain rule rather than quotient rule? Okay, so let's go ahead and do that. I'm going to erase this. Everybody good? Have I lost anybody? Okay. Okay, so x plus 1 divided by 2x minus 1 can be rewritten as x plus 1 times 2x minus 1 to the negative 1. Okay, is everybody okay with how that happened?
There you go.
Okay. So we're going to take the derivative of the first times the second plus the first times the derivative of the second. Everybody okay? So the derivative of the first is 1. And then times the second as it is. So far, so good. And then plus the first times the derivative of the second. And that's where chain rule comes into play.
Yes.
So times negative 1, 2x minus 1 to the negative 2, and then times 2. Now, that looks nothing like, our goal is to make it look like negative 3 over 2x minus 1 to the second, right?
Yeah.
Are we good so far?
Well, there's a lot of things you can bring down.
So there's a lot of things you can break down. Now, this is something I haven't shown you before, which I think is pretty cool to watch, to see. Now, if I scan my eyes across between the 2 sections, does everybody see where the 2 sections are? The first section is this guy. The second section is this guy. It's ugly and big, right? So let me do an aside. Don't write this down. And I tell you to factor that. Tell me in words the technique you utilize to factor that. What do you recognize? What do you have to recognize first?
They're both powers.
They're both to a power, okay? You're looking for the biggest one that'll go into both. Does that make sense? So if this is squared and fifth, what's the biggest thing that'll go into both?
X squared.
Squared. So when I take the x squared out, what's left? Well, that becomes a
X
1,
or
right?
1.
And what's left here?
X cubed.
So is everybody cool with how this happens? That makes good sense, right? Okay, so let me blow your mind a little bit here. Looking at this.
Oh,
Okay.
that's really cool.
So remember how we did this was we looked for the smallest thing and pulled it out
Yes.
that they had in common. Over here. What's the smallest thing that they have in common?
2x minus 1 to the negative 1.
Oh.
So negative 1 or just that?
That's a good question.
Goes into both.
if this was a 1/2 and a 3/2, you'd pull out a 1/2 because it's smaller. What's smaller, -1 or -2?
Oh, -2. Right, they're negatives. Because
That's confusing.
it's very
What is smaller as far as...
value-wise. It's -2.
So how do you?
So, how did that happen? Let's look. Okay, so this is why I use quotient rule instead of this rule, okay? So here's how this happens. When I did this, let's review for a minute, and we factored that out, we took it out and we said, how did we really get the numbers that happened here? Well, remember we subtracted the exponent? It would be x to the 0 left over, which is 1, plus x to the 3rd. You understand where I'm coming from? Subtract that exponent, okay? So if I'm pulling this out, I'm going to subtract the exponent from it, okay? So -1 minus -2. -1 plus 2 is what?
1.
To the 1 whole. So what I'm left with here is 2x minus 1 to the 1 whole.
Okay.
Plus, we didn't do anything with this guy. We didn't do anything to this guy. This has been pulled out
So it does 1.
times that.
Okay.
Are we good so far? Okay. Now, this is going to go for the ride for a moment because I factored it out. Okay. What do I do inside the bracket here?
Clean it up.
I'm going to clean it up, right? So I've got what? I've got 2x minus 1. And then, do you guys agree this is really -2?
-2x minus
Each of
1.
these guys, right? So minus 2x minus 2. So
Or,
far, so
yeah,
good.
minus 2.
Okay, so clean her up a little bit more. So I've got 2x minus 1 to the -2.
And then 2 x's cancel out, and then you have -3. And then the -2. Oh, okay.
And that could flip to the bottom. So I'm left
That's just
with,
a long way around.
well, you guys want to do the product rule with the chain rule.
Yeah.
Never mind.
Never mind. So why do we need to know the quotient rule? I tell you, that's why. Do you see the difference though?
Yes.
This was truly step 1, step 2, end, right?
Step 1, step 2, step 3, step 4.
And then a lot of thinking and mistakes could potentially be made.
Oh, a lot of
Because
mistakes.
do I know that -2 is smaller than -1? Sure, I know that.
But you don't think
But I
that.
don't think that because number 2 looks bigger.
Right.
Physically it looks bigger.
I had the
So.
one.
Are we good so far? Okay. All right, good luck there. All right, are we comfortable so far? All right, so let's good. So power rule, product rule, quotient rule, chain rule, comfort level?
Pretty good.
Let's never do what we just did again.
I actually
it looks
like it.
amazing,
I do.
but it's too much work.
Yeah, I do like it. Okay, so let's go back to the trigonometric functions. Okay, so the derivative of sine and cosine are the only two that you're going to have to absolutely 100% know. They're on your bright colored sheet of paper, so you don't really have to know them. But it's not a bad thing to know them. Okay? The derivative of sine is
Cosine.
cosine. Okay? And I showed you last year through graph. So I'm going to say this is y and this is y prime. Are we good so far?
Yes.
What is the derivative of cosine?
Negative sign.
It is negative sine. So Nick went home and studied this weekend. Am I right? Good man.
Well, and I figured since it's on the colored sheet of paper, we don't really need to focus that much on
You
it.
don't really need to focus that much. Now, the rest of them are not on the colored sheet of paper. Maybe they are. I don't know. But let me show you how I know them pretty easily. What is tangent equivalent to?
Sine over
It
cosine.
is sine over cosine. You guys all agree with me? So I'm going to take tangent. Rather than tangent, I'm going to call it sine over cosine. Okay? And I want to derive it. So if I'm looking at this thing, I see that it's a fraction. So which derivative rule will I use?
Quotient.
I would use quotient. Once again, why do we need to know the quotient rule, right? So what do we have here? So for quotient rule, we go low d high minus high d low over low low, right? So what is it going to be? Low d high, derivative of sine,
Cosine.
minus high
Sine.
d low
Negative sign.
all over low low.
Okay, and then so it's
Yeah.
cosine plus sine, or cosine squared,
Plus sine squared,
which is 1.
Okay, so let's cosine squared. Let's just slow it down and make sure everybody's on the same page,
Sine squared. Those are cosine squared.
right? And what's cosine squared plus sine squared?
One.
whole. Pythagorean identity tells me so.
Mm-hmm.
So it's 1 over cosine squared.
Also known as secant squared.
Correct. The derivative of tangent is secant squared.
That's beautiful.
Isn't that nice? How would you rewrite cosecant in order to be able to use the quotient rule to find its derivative?
1 over sine.
Try it yourself. 1 over sine. Give it a go. 1 over sine. What's the derivative of 1, by the way?
That's
0, right?
Oh, so it's 0.
Yeah. Well, not the whole thing.
Well, it's because it's 0 divided by something.
Well, you're going to do low d high minus high d low over low low.
Right.
be a negative something.
I give you 2 seconds to give it a try, a whirl, and I'll help you through it. Michael, you doing okay? You need a hint?
Yeah.
Absolute values do what to both sides? With the absolute values do what to both sides?
Yeah.
Yeah.
Michael.
What should you do? D high, so far so good.
Perfect.
Okay. Minus high, what's D low?
Negative sign.
Or cosine.
Correct.
Derivative of sine,
Yep.
right? All over low low.
All over sine squared.
So far okay?
Yes.
0 times anything is 0.
Yes.
So I've got negative cosine
All over sine.
over sine squared. But it's really negative cosine over sine times 1 over sine. What is negative cosine over sine equivalent to?
Negative cotangent.
Yeah.
Sine.
Negative cotangent. And then
Times 1 over sine, which is cosecant. And
the derivative of cosecant
this is negative cotangent.
is negative cosecant cotangent.
Wait, what?
Yeah.
I just flipped it around.
Wait, isn't that itself
Wait, what?
derivative?
Okay.
I feel like this is sort of similar to you showing us that, like, the E and...
Yeah, it is. I mean, I could just flat out tell you what their derivatives are and we'd be done, but
Nah, this is more.
it's kind of cool to see the methodology behind it. What about secant? It's 1 over.
1 over cosine.
Okay, so let's do it. 1 over cosine. Low, d high,
Cosine
similar,
times 0.
minus high,
1.
d low,
A negative sign of x.
all over.
Cosine
Low.
squared x.
Okay.
Uh,
So 0 plus sine.
Yep.
So we have sine over cosine
Yep.
Squared.
Cosine squared.
times 1 over cosine.
So that's
So sine
Tangent,
and sine secant.
or C.
right? And it is secant tan.
Does it matter the order?
Yeah, S comes before C. I don't know why cosecant came before cotangent.
Because I guess it is
Miss K.
cosecant.
What?
You said C.
I meant that. T. Sorry,
You're good.
brain's not going in the right direction.
Wait, why is the order not?
It doesn't.
But
Oh, okay.
cosecant would come before cotangent. S is half of
Don't
it.
worry.
Okay, so
I'm not even.
for a mathematician,
Mm-hmm.
secant tan comes naturally like 2x instead of x2. Does that make sense? It's not wrong, x2,
Yeah.
but
Why would
it's
you-
wrong. You know what I mean? Because it's like visually it should be 2x.
Like reading right to left.
It's weird. Yeah. So I mean, eventually you just become natural with it, and it feels like that's the way it's supposed to be. So go ahead and try
Even
cotangent.
if they cancel it, they have to give you.
I'm sure they'll do
They'll
something
give
to.
you a retake, probably.
Okay, cosine over sine, right?
Mm-hmm.
So low D high, low
Negative sine.
D high
Minus
minus high
times cosine.
D low
All over sine.
all over low low. Everybody good with that so far?
Mm-hmm.
I get that.
Yay. So now we have negative sine squared minus cosine squared, right? You can get rid of the negatives. How?
Divide by.
Split them into two pieces.
No. Can you factor out the negative? What are you left with?
Negative 1.
Oh.
Plus 1.
So you have negative 1 times sine squared plus cosine squared.
Which is 1.
Make sense?
So it's
Yeah.
negative sine squared.
So it's negative 1 over sine squared.
Negative cosecant squared.
Plus 1. But it's
It's
negative
times.
Mm-hmm.
So
Oh, times.
this all becomes the number 1.
Yeah.
Yeah.
Oh,
Negative
it's
1 times 1, right?
1 over sine.
1 over sine squared, negative 1 over sine squared. So, what do you think? Yes, no, maybe so? Wow, I love this stuff, Miss Kay.
Mm-hmm. Pretty neat.
It's a thing.
It's a thing.
No.
It's a thing.
Okay, so, homework papers. Let's look at your homework. Everybody, everywhere. Okay, so, if I look at the first quadrant. Anyway, I don't even know. Top left.
Top left. It'll be okay, Ryan. We can get through this. I'm done.
Okay, so top left.
Yep.
Each of these problems 1 through 10 are product rules.
Yes. It says that.
Some of them involve what rule?
Chain roll.
Okay.
Anything
So you have a little bit of product rule with some chain rule kind of intertwined. Okay, move your eyes over to the right. Once again, these are called the product rule, but now it's bringing in sines and cosines.
And E of X and log and
Still don't get
E
Which
to
we'll
the
do.
5x. What?
Still.
Hold off on the log ones, I'll explain those later.
Thank you.
Okay? Go down to the bottom left, find the derivatives using quotient rule. Low be high, minus high be low, or below low, there might be some chain rule, especially like number 3, number 7. And then moving over to the right, same kind of thing, but it has some LNs and some E's and some signs and
Yeah.
fun.
X to the 7th fifth.
Okay.
What?
yeah, that's
Ooh.
ugly.
Mine is X to the 8th fifth.
Oh,
All over.
the 5th root of X.
X.
That's ugly.
Nah, man.
Don't let a root scare you.
I ain't about that.
Numbers don't
I am
say.
about that.
And so let's look at first quadrant, first left, top left.
Yeah.
Which one do we think is most difficult? 9?
Yeah.
Sure.
Yeah.
Just say yeah.
Pretty ugly.
Yeah, sure.
Let's do one together, make sure we're on the same page. Okay? So y is equal to, and instead of the square root, I'm just going to rewrite it first.
Yes.
To the 1/2.
Are we good? Okay, so this is a product rule with a little bit of chain rule excitement inside. So remind me, product rule, it's the derivative of the first times the second plus the first times the derivative of the second.
Mm-hmm.
The beauty of calculus is when you do this, you don't really have to clean them up. Just do the calculus of it, okay? So the derivative of the first is 1/2.
1/2 sine x squared plus 1
Two.
times 2x.
Times.
What about this guy?
Oh yeah, negative now.
Uh-huh.
Times 2x.
Times 2x. Questions, comments, concerns, issues. Derivative of the first.
Let's do quotient.
Are we good?
Mhm.
So first, derivative of the first times the second.
Isn't there
With the 1/2.
plus?
Okay, plus,
Oh,
we did the derivative of the first times the second,
The 2x,
plus,
what, is the 2x the derivative of the inside? What is that?
yes. Did you want any helpful hints? Did you? Now, the next one. So derivative of the first times the second plus the first
There's a lot of twos.
times the derivative of the second, which is 1/2 times times x squared minus 1
To the negative one half.
to the negative 1/2 times 2x. Now, let's just play for fun. If we were going to clean it up, did I go too fast? No, are you good?
No.
I was
Can we pull the names
I was
out?
labeling my paper, and I looked up, and that was on the board. So.
I even stopped to help Nick. Are you still writing your name? Oh my goodness, you were.
Well, I understand it. So
Let me
it's
hand my
okay.
paper. Oh, it's done.
That's exactly what
Okay,
happened.
that helps.
I looked
Okay.
up and there was two.
So let me show you, if I ask you to clean it up, how it should happen. Say, do you
We do the
agree
same
this
thing as
guy
that
and
one.
this guy are in common?
Yes.
Mhm.
Okay? What's smaller?
The negative one half.
So that's what I would pull out. Again, do you see in common,
Oh.
smaller?
Yeah. Yes.
Now, what's left, I put in brackets. So do you agree basically that this is gone,
Yeah.
right? And do you also agree that these two things multiply to give me an x?
Uh-huh.
Yeah.
Okay? When I factor that out, remember it's, yeah, because I pulled out negative 1/2.
Negative one.
So it's 1/2 minus negative 1/2. So it's times x squared plus 1 to the first. Are we good so far?
Yeah. Oh, okay.
Okay. Now, same concept on the other side, because I've factored out the negative, it's 1/2 minus negative 1/2. So it's x squared plus 1 to the
Where did
first.
that first x come from? In the brackets?
1/2 times 2x.
Gotcha, that gets us.
Okay, and so this guy's gone, and these two guys become x.
That's really confusing.
Yeah, me too. Did I forget a negative somewhere? Yes.
Just kidding.
Why is
Yeah.
that?
Is this the easy stuff?
No.
So, I mean,
This,
there will be
this
harder
problem
stuff.
is done.
Yeah.
You leave it like that.
Aren't the
Can you leave it
vectors
like
in
that and
this?
get points?
Aren't the vectors this year like unbelievably hard? Because I heard from Cassidy that they were really difficult.
Vectors? I don't
Yeah.
even remember
Oh,
vector
yeah, I don't
problems that we
remember.
had.
Is it three-dimensional arrow thing?
Yeah, the three-dimensional arrow.
I kinda like that
is harder.
section.
Yes.
Wait, so what do we do after that?
Why is the in the brackets, the x squared minus 1, why is that to the 1 again? Because of the,
So when I factor it out, it's 1/2 minus negative 1/2, which becomes 1/2 plus 1/2.
okay.
And that's the same with the other one too?
Yeah. So now you distribute this through and get x cubed minus x, right? Plus x cubed plus x, and the x's would cancel.
Why do I feel like we've never done a product rule?
We touched on it.
We touched on it,
I
but we
remember
never
doing
ever
example
did
problems
any
with it.
Yeah, I feel like we
I don't
never
remember
done
using
that.
Yeah,
We didn't really
this
use
just
it.
looks like it's for
It's
it.
horrible.
It
Now-
literally cancels out everything.
It cancels out.
Not quite, because this goes away, and we're left with 2x